big trick with this question is that none of our units match. Right? We're given our velocities in meters per second. Okay? We're given our times in hours. We're given our distances in kilometers. Okay? We need all of them to match. So the easiest things to do here would be to convert the hours to seconds. How many seconds in an hour? 3600. We talked about that yesterday. Okay? And converting the kilometers to meters. Okay? Because we went over the metric system yesterday, we should all remember that kilo means 1,000. Okay, so there are 1,000 meters in a kilometer. Okay, you need to make those conversions before you can start doing any V equals D over T stuff. Okay. So just like any of the other kind of multi-part V equals D over T questions that we did yesterday, okay, this one we want to set out our givens first. So in part 1, okay, the elephants travel for 1.1 hours, which I want to convert into seconds by multiplying by 3,600. That should be 3,960. Not because I calculated that in my head, but because I remember it from yesterday. Okay? So it means I'm old, but I don't forget everything. Just my wallet when I go to Walmart or notebooks. Okay. We also know that they walk at a velocity of 3.0 meters per second. Okay. In part 2, okay, they walk 7 kilometers south. So that's a displacement. Sorry, this should have an arrow over top as well. That's north. Okay, 7,000 meters south. And that takes them 1.5 hours, which should be 5,400 seconds, right? Okay, that's what we know for part 2. And then we have part 3. Okay, and in part 3, they walk at 4.5 meters per second north for another 2 hours, which should be 7,200 seconds. Okay, so that's the stuff that we know. If I want to calculate the overall distance and the average velocity, then I probably need to know how far they go in each part of the trip. Agreed? Do I have that information? No. I know how far they go in part 2, but in parts 1 and 3, they only tell me their velocity and their time. Can I use that to get how far they go? Yeah, I just do a V equals D over T calculation. Okay, so I take V equals D over T, and I manipulate for D by multiplying the T over to the other side. So D will equal V times T. That'll be 3 times 3960. Okay, so they're going to walk 11,880 meters. All right, and that's north. Don't have to do anything in part 2 because they already give me distance and time, or displacement and time in part 2. And then I have to perform the same calculation here in order to get how far they travel. 4.5 times 72,000. Or sorry, not 72,000, 7,200. Okay, so 4.5 times 7,200. All right, 32,400 meters north. Okay. I want to calculate the total distance walked by the elephants. Does direction matter for that? No. I just need to know how far they walk. So what do I do with the 3 Ds? Add them up. Okay. So that'll be plus 11,880 plus 7,000. All right, so they walk 51,280 meters. That's their total distance traveled. Okay. Now, in order to get their average velocity, what 2 things do I need? Total displacement and total time. Yeah. Okay. So in this trip, they go north, then they go south, and then they go north again. So how can I put those things together?
And you can add those 2 parts together. And you can subtract, you can just, that can be your average, that could be your total displacement, because this is actually not on.
Okay, you're on the right track. I do want to add them all together, but what do I need to do with the 7,000? Yeah, or make it negative, because I said I want to add them all together. This is kind of the first steps in what we in physics call vector addition. Okay? And we always call it vector addition. We never call it vector subtraction. Okay? We just add things together. The things that are backwards, we make negative. Okay? So all I would do here is I would take my 11,880 plus negative 7,000 plus 32,400. Okay? So really, I'm just going to take this number and subtract. Okay, well, we'll try it again. So 32,400, that's north, okay? Plus 11,880, which is also north, plus negative 7,000. All right, gives me 37,280 meters. All right, everybody okay with that? Okay, 37,280. Meters north. Okay, what do I do with the times? Add them up. Okay, so we had 3,960 plus 5,400 plus 7,200. There's our total time. So I've got total displacement and total time. I'm going to divide those two numbers. 37,280 divided by, that's 16,560. Average velocity, okay, of the elephants. Okay, is going to be 2.25 meters per second. North. Okay, do I have to include the north? Yep. Yes, velocity is a vector quantity. If I don't write north, it's wrong. Okay. All right, does everyone follow how we did that? That is a very typical type of V equals D over T question, because on a test, I'm not going to give you a V equals D over T question. That's just, here's a D, here's a T, calculate V. Okay, that's beneath you. Right? This makes you do a little bit more work and think a little bit more. All right, so expect you to probably see something more like this on a quiz, okay, or a test. All right. So, speaking of easier ones, okay, I want you guys to try a few easier ones from the worksheet booklet, okay, just to kind of get the hang of it and make sure that we're understanding the vector kind of scalar stuff a bit. All right, so I'm going to put those up on the board. We'll work on those for a bit, and then we're going to start on to graphing today. Okay, so this is just like the bus question, right? It's a question that has two parts to it that have different velocities. Okay, so during part one, the person is in free fall. Now, in reality, when you're free falling, you're actually accelerating. Okay, you're not falling at a constant velocity until you reach terminal velocity. Okay, which is kind of what we're saying they're at here. Okay, terminal velocity is the fastest you can fall because the force of gravity pulling you down and the force of the air resisting your falling balance, and you can't accelerate anymore. Okay, depending on your shape, that is a different number, right? So if skydivers want to fall really fast, then they tuck their hands behind their arm or behind their shoulders like this, and they kind of fall in that torpedo shape. Okay, if they want to slow down, then they put their arms and legs out to the sides and they slow down a bit. When they open their parachute, obviously their terminal velocity is also a lot lower because the parachute has a lot more drag. Okay, so in part one, we know that they're going to fall 625 meters. And they're going to do that in 15 seconds. And then in part two, with the parachute open, they're going to fall 356 meters, and that's going to take 142 seconds. All right, so if we want to find her average velocity with both magnitude and direction, then we need to find the total displacement and total time. All right, so average velocity, okay, will be 625 plus 356 over 15 plus 142. Okay? So really what we're saying here is D over T. Okay, so 625 plus 356 divided by 157, right? Right, gives us 6.25 meters per second, and the vector is down because you can't fall up. All right, any other ones giving us trouble? All right, then let's move on to graphing here in a minute.